paper?
No, they just all just, but it was twice. I did it twice, like within 5 minutes. It was of the other kids, and everybody, he just kept talking about it, like, whatever, was like, I don't know. So it must be some damn kids. Yeah.
Yeah.
How many other trees?
Yeah, I think.
No way.
Yeah. That's why I wanted to take it. Yeah. It's because it's not probably not. She's probably taking that semester.
You guys are scholarship, that's it. You guys just keep it somewhere.
What I could?
Yeah. I have a shorter concept. Yeah. Sometimes I paste them together. It's over. So bad. I didn't play earlier. Well, I did with my ACT scores. And I had to go regularly this week.
Yeah. See, it was weird because I felt like you weren't like you didn't have to go to your ACT scores. And then I
Yeah.
They wrote an essay for the honors application.
Yeah.
And you can't get into it without being early.
But now,
Okay.
What about for, that's like honors or like scholars? Yeah. You have to do the early access to the scholars. Because I was sitting in the early level, yeah. I mean, you just like the learning. Yeah, I was like on that portion, just like,
yes, sir.
Yeah.
Yeah, I know.
Why was it not?
Well, we can't solve the
Biology.
I'm gonna do biology.
Oh, well, that's better.
Yeah.
Maybe we'll all be in the same biology classes.
Hi, Eddie.
Yeah.
I'm so bad at biology.
You're bad at biology?
No. No, you gotta be a person.
What? No, I don't.
Hello. So how did we do last night? Do you want me to go over these answers? Make sure we understand what's going on here? Yeah. So the first one, the region is looking like this. Yeah. That's what the region looks like. And then so the first one is rotate these about x equals 1, which that's just like rotating it around this right here, yeah? So we reflection. And then I think I'm gonna a stack of these are like a pancake. So for this one, our integral should be this. That's 1, 2, yeah? So it'll be from 0 to 2 of pi times 1 minus 2. Whoops. So this is y equals 2x. So that's x equals y over 2. Do we get that? for our first one? Yes. Did I do that right? X equals 1, yeah. Question. Okay, next one. Same region. Now we're going to rotate it about this line, which is x equals 2. So we are stacking still like a pancake. And so this one's going to be from 0 to 2. The outer radius is going to be 2 minus y over 2 squared. And the inner radius is going to be, that's x equals 2. 2 minus 1 squared. Does this look funny to you? That's supposed to be a y, but it certainly doesn't look like a y. I don't know if that helps. Question.
Can we simplify like the 2 minus 1 and just put 1?
Well, of course you can simplify that, Ellie.
You just like
I'm actually purposefully writing it like that so that you can see where it came from. Like, I mean, and I'm just wanting to be consistent with making sure that we understand that that is the distance from 2. It's like that 2 is bigger, you know. Okay, so the next one. So the region is y equals x squared and y equals 1. So, oh, I guess the whole y equals x squared, isn't it? Okay. So now we're going to revolve this around y equals 1. So that's, we're going to find this like egg looking thing, going with that egg looking thing. And I guess we'll stack these like pancakes since that's a horizontal axis. Ooh, yucky. Okay, so here we go. That's still going to be a disk and not a washer. There's no hole in that, right? Okay. So this one's going to be the integral from we need to know what that point is. So that's y equals x squared. When does that equal 1? Oh, that's at plus or minus 1, right? So this will be from -1 to 1 of pi. What's the radius? What's the radius? Is it always 1? It's only 1 right here. Well, the radius is that length right there, right? And what is that length? It's 1 minus x squared. Yeah? Questions on that? Yeah.
Could you use it in terms of, or could you do it in terms of y?
Could you do this one in terms of y? You mean stack these like, well, let me make sure I. So you're saying then the radius, the discs will look like this, yeah? You good with that? So then you're going to say that's going to be from 0 up to what? Okay, you got to be careful here. Okay? What I'm going to do It's not 0 to 2. Okay? I'm going to do 0 to 1, and I'm going to double it. And then I'll explain to you why it's not 0 to 2 here in a second. So that's going to be pi. I want to make sure you have the shell or the disk right. It'll be pi times, what's this length right here? Okay, actually, isn't that length right there just radical y? The 1 doesn't come into play there. Okay, now why can I not use 0 to 2? Okay, the reason I can't use 0 to 2, and I have to actually find up to right there and then double it, is because this parabola, like this disk right here that you're stacking up, only is true up to 1. If you keep going on this curve up past y equals 1, radical y is going to be out here. You see that? So that's why I'm just using the symmetry and doubling it. This integral right here and this integral right here, if you compute both of those, they're going to get the same answer. Okay? That was a good question. Okay, what's the next one? We needed, so that was around y equals 1. Okay, let's go around y equals 2. So same thing here. I think when we do this one, since this is a horizontal axis, I'm going to stack these like library books. Okay? So now I'm going to integrate from -1 to 1 of pi, the outer radius. Okay? The outer radius is the distance from here to right there. And what is that distance? It's 2 minus x squared. And the inner radius is the distance from here to right there, which is 2 minus 1 squared. I don't know why I put an extra set of parentheses there, but I did. Okay, now Ellie wants to write that as 1, and that's okay. All righty. And then the last one. The last one was the hardest of all of them on. I'm curious to see how many you did it right. Okay. So the last one was y, revolve that baby around what? Y equals. Oh, that's embarrassing. Revolve that around what? -1, which is down here, right? Okay, so what's that going to look like? Yes? And then we draw the disk. So since this is a horizontal axis, and we're going to do this by stacking, we're going to stack like library books. Okay? So I draw this rectangle here, and I spin that baby. Okay? So our integral is going to be pi, the outer radius. Okay. Okay, here we go. outer radius is the distance from here to there. What is that distance? Well, this is y equals 1, right? This is y equals -1. That distance is really 1 minus -1, right? Which is, we all know as LE 2, okay? And what's this distance right here? The inner radius is the distance from here to there. What is that distance? Okay. Well, it's really x squared minus -1. Right? Because when you find distance, you always subtract. It just so happens that when you subtract a negative, that's like adding, right? Ribbit. So if I were to, and then the bounds, I guess, didn't change. So if I want to rewrite this for Ellie, it's going to be this. 2 squared minus x squared plus 1 squared. Okay. How many of you saw that? Like the plus 1, that ended up being plus 1. How many of you saw that last night? Like when you did this? You figured that out. The rest of you didn't see that? What did you do? Right here? Okay, where'd you get the 2?
Top. And like, that's like the radius minus. Like from y to negative.
So you're saying that distance right there is 2, right?
Yeah.
You see why that's not right? You were measuring the wrong thing, I think.
I don't.
Well, where did you had 2 minus x squared was your measurement for this, correct? And you said you got that because that distance is 2. This, okay, I'm going to blow this picture up for you, so hopefully you can see this. Okay. Okay. So what we're trying to find, right, is this distance from there to there, right? The distance that you found, here's 2 up here, right? You found that distance minus this distance, right? That's x squared, that's that distance. So you found that distance right there. Now, are those the same? You're guessing. Yeah, prove it to me.
All right, let's say it's like the very last one. I have 2 minus x squared, and x equals 1. That means 1 squared is 1, 2 minus 1 raised is 1. That's how.
So right here, very nice. Right here, Okay, you found this distance, I mean, it would be that right there, which is 1, right? But that point right here, it's way bigger. Okay? Perfect. That's not what I was thinking. That was actually simple, way simpler than what I was thinking on how to prove that. I was just thinking algebraically they're not the same. Like 2 minus x squared is not algebraically equivalent to x squared plus 1. Like, it would have to be, right? Very nice. Yeah.
Oh, okay. I did -1 minus 1 and then -1 minus x squared. Would that still work since you're squaring them?
Okay, so that's a really interesting question. Did you guys hear what she asked? She has a mask on, so you can't understand her. But she said she flipped these, and she flipped these. Since you're squaring them, it really doesn't matter because it comes out to be the same number, right? So technically speaking, it's right. And I think as long as you can rationalize that, like, that's okay. I remember grading the AP test years ago. And on the AP test, when students did that, when they flipped those and they squared it, there was a big discussion as to whether or not they would award credit for that or not. And it varied from year to year. Like, some years they would say, yeah, it was okay, and then other years they wouldn't. And really, it wasn't a matter of necessarily correct or incorrect. It was whether they needed to grade it consistently. And whoever was in charge of the question, they decided, well, we're going to say yes to giving them credit for that, or we're going to say no for giving them. And if everybody does it the exact same way, it doesn't matter. It comes out in the wash. But, I mean, technically speaking, if we're thinking about the actual integrand representing that disk, it wouldn't be right. But I don't know that I make a huge deal of it. So I won't freak out. Megan, what was your question?
Why is it x squared minus?
Why is it x squared minus -1?
I got what's on.
Okay, Emily, Megan? How far is it between there and there? How'd you get that? You just did 3 plus 5? Like, because you just thought about that, like, oh, that was 0, so this was 3 and that was 5? Okay, fine. What's the difference between there and there? 16. How are you getting that?
I learned it like do it.
But what are you doing when you're doing that? Where did the number 16 come from? I mean, you're not pulling 16 out of thin air. It's not like, oh. That's coming from somewhere, right? Where's it coming from? Well, how did you get it? Okay, fine. It's just happening so now. Whoa. What's the difference between there and there?
I don't know.
You don't know. Well, what are you going to think about? Maybe you really didn't know where the 16 was coming from.
It's just like habit. It's like, okay, I would add 1 to 220, and then I would be like, okay, so that's, 219, that's 220, and then I would add 80, which is 300. 80 plus 71 is something, and then I would subtract 1 again.
Yeah.
You're going through a strategy on how to do this computation. What computation is it that you're doing? You're not adding. You're subtracting. Like when
In
you
my head, I'm adding.
when you did this right here. Okay? You really did 5 minus -3, which is 8. When you did the next one, what was it? 6. What did I say? Well, I forget.
16, 20, 4.
Oh, 20 and 4. So 4 and 20. Right? What are you doing there? You're really saying it's 20 minus 4. To find the distance, you just take the bigger one minus the little one. The littler one, right? So over here, where are we? Right here, okay? To find this orange distance, you're going to, which one's bigger, x squared or -1? X squared. So to find that distance, you're going to do x squared minus -1. X squared plus 1. So now, ironically, what you were explaining to me was a strategy on how you would subtract 219. Wait, that's what you were doing there. But I guess you just didn't realize you would subtract. Yeah.
I think maybe the people that did it that, like how Colin and Megan did it, thought that x squared was the distance between y equals 1 and x squared. Because then that would work, but x squared is underneath the 3.
Say that again, Abdel.
So like it would work if it was 2 minus the area underneath y equals 1 until the curve.
You're going to come here and I don't. You said area there, and I don't know if you meant area.
I don't think I meant area,
But
Like from here to here is 2.
put
And-
dots there or something so I know what you're talking about.
From here to here is 2.
Yes.
And then I think they meant to subtract this from that instead of this. So like that, if that was x squared, then it would work, but it's not.
But that is x squared.
I was
What?
It's just the wrong distance.
Yeah, I always think about it that like if you're doing the integral of x squared, it goes all the way to -1. I always forget it stops at.
And the other piece of this here is the integral that the area under the curve and any of that like that's it. It's completely doesn't matter when it comes to this. Okay, the deal is you draw that washer and you measure those radii of that washer on your picture. Okay. If you try to do this, especially when you're first learning it, I can do it. I can look at one of these in my head and just do it in my head, like we just did it, because I was just giving you the answers, right? But if you try to do this without drawing the washer and physically measuring those distances, you're not going to do it right. You've got to measure them. And when I say measure them, I don't mean with a ruler. I mean identify the distances from your picture. Like you need to have that conversation with yourself. Like, okay, this outside, that's going to be the outside radius. That's the inside radius. What are those distances? Always, always, always go back to the original region. Don't go to the reflected region. That's another, I said that yesterday, but it's really easy to want to go down here and start messing around with this down here. If you do that, you're going to get it wrong every time. Okay? So like in this particular problem, that length right there, what does it mean for this particular problem? Like the way we set this up with that washer. What does that orange length mean? Nothing. Like this length right here means nothing for this setup in this context. Now, yes, have we had problems where that length is important? Absolutely. But in terms of the measurements of the washer, that orange length doesn't mean anything. Now, it doesn't look orange when I look at it from over here. But you guys know what I'm talking about, right? The distance between y equals 1 and x squared. Okay? That distance doesn't really do anything for us because it's not either one of the radii. Okay? Other questions? Okay, what happens? Let me do this. Let's see. So here's what's going to happen tonight. I've got a whole bunch of problems from your book that I'm going to have you working on this to practice this. I will put tomorrow either a video or just a worked out solutions to all these problems. I haven't decided if I'll make a video or just write them all out on a piece of paper. I'll decide that today. What I'm about to show you right now is like kind of a preview of what's going to happen on like the next thing. Like what happens if you can't, like say we're going around a vertical axis, right? If we're going to go around a vertical axis and we're going to stack, how do we have to stack? Like pancakes. And in order to do that, it requires you to have to be able to solve for y, or x in terms of y. What happens if you can't? You just don't do it. That's what we would do right now. We would just say, oh, he screwed up. He gave us the wrong problem. Okay? So what I want to show you today is we're going to like kind of unpack that, like what that looks like. Right? But you're not going to have any problems to practice that. Yet. That'll be on Thursday. So let's just make something up here. Let's make a graph. I'll give you a graph. What if I make up a region like this? Y equals negative x, oopsie, minus 2x minus 4. Okay, and y equals 0. So here's our region. I'm just curious right now before we even start the calculus. How many of you, if a metaphorical gun were held to your head, could sketch that region, get a decent image of what that region looks like right now, without any help whatsoever? Should we be able to do that? We should. The first graph, what is it? It's a parabola. It's upside down. Where are the zeros? 2 and 4. Do I care necessarily where the vertex is for this? Maybe, maybe not. I mean, but I can at least sketch something. I can go back and find the vertex later if I have to. I know the vertex is halfway between the two zeros. So, okay. Is that good? Good enough for you? 2, 4. Boom. Vertex is at 3 something. I mean, if you had to find the vertex, if I was like cocking the trigger, You can probably find it now, right? Because you know it's a 3. Y equals 0. You know what that is. Please tell me what that is. So there's our region, right? Okay, so rotate this region about the x-axis. I'm sorry, the y-axis. Rotate that about the y-axis. Boy, that's scale is kind of off, don't you think? Don't tell anybody. So this region, when I rotate it about the y-axis, is going to look like a bundt cake. You guys know what a bundt cake is? Or it's going to look like maybe the top half of a bagel that's been sliced. Okay, so lightly, with your pencil, sketch the washer that you would be stacking. Lightly. I'm going to do it lightly too. I feel like when I'm doing this lightly, I should be whispering. Does everybody have something like that? Yeah, this is no big deal, right? What's the inside radius of that washer? The inside radius is 4. Well, the radius is the distance. Is it always 2? I mean, it's only 2 right here. The inside, I mean, they're changing, but the inside radius and the outside radius are both changing, yes? What's the inside radius? Well, it's that distance right there. But what's the outside radius? It's this distance right here. Those distances are both on the same curve. That's a problem. Right? How are we going to do that? You see what I'm saying? Those distances are defined by the same curve. Which turns out that function y equals blah, 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 x minus 2, x minus 4 negative. Y is a function of x. But x is not a function of y. Okay? That function does not have an inverse. That is a function. It fails the horizontal line test. Remember that from like algebra 2 pre-calc days? So this disk method, this washer method, is not going to fly. In fact, I cannot algebrate this. I can't solve this for x in terms of y. Can't do it. So what are we going to do? Well, this is why I said lightly. Has anybody ever seen those Russian dolls? You know what I'm talking about? Those Russian dolls that are like nested. Like you open up the doll and then there's another one, you open up the doll. Okay? Or like if I have this is a tape measure. But like there's a solid right here. Does everybody see that solid there? Okay. This kind of has that same Russian doll feel to it. What are nested on top of each other there? They're like little cylinders, like, right? Well, what would happen if instead of drawing that rectangle like we draw, and we spun that around, instead of drawing that horizontal to stack like pancakes, what would happen if I drew that rectangle like that? And I rotated that rectangle around the axis. What's that going to look like? What is that? What do you see there? Or what do you see half of? What? It's like a cylinder. Right? It's like a cylinder. How thick is that? Thick AF. How thick is this right here? Well, it's infinitely thin, okay? But so is it dx or dy? I didn't hear a universal dx there. Okay? When that rectangle looks like that, it has dx thickness. When that rectangle is on its side, it has dy thickness, right? This is dx thick, right? Well, a cylinder, can you tell me what the volume of that cylinder is? A cylinder, I mean, this is what it looks like, right? That's what it looks like. How can I find the volume of this piece of paper? You know, Joe? Or this tube?
Like the area of the big circle times the height of the cylinder, and then minus the area of the little circle times the height too.
Okay, there's an easier, yeah, you're right, but there's an easier way. If I want the volume of this piece here, I'm not saying how much will this hold, I'm saying the volume of this if I unroll it. What's the volume of this piece of paper? It's the circumference of this circle, right? Times the height. Like, think about it like this. If I unroll this, I'm going to put this in the camera so people can see. If I unroll this tube, oh, crappers. If I unroll this tube, it's going to be that circumference times this times the thickness. That's the volume of this piece of paper, right? This sheet. So then, what's the circumference of that thing? 2 pi r. What's the radius? We'll have to do that on Thursday. Yeah. There's way too much there. I mean, I'll keep you another period if you want to just keep talking about it. So look on the Google. There'll be some problems for you to try. In fact, I'm going to type them up right now and put them on there. On the Google. Right now.
Say, bitter cow for one, cow.
Show me your book. I asked this one, if I could do your book. And then everyone's like, there's like multiple people on customer. It looks so good. Oh, yeah. Which one? It's really high on Amazon. Oh, and I bought it. It was like $4. Oh,
I'm going to get pancakes tomorrow for breakfast because we keep talking about pancakes.
You're gonna have pancakes tomorrow on weekend Wednesday?
Yeah. Me and my boyfriend are gonna go to the pancake house.
You and your boyfriend? Who's your boyfriend?
Jared Tackett. He's not good. Did you know Lauren Tackett? She graduated last year.
Doesn't sound familiar. Oh, I didn't sanitize. Carrie, you wanna take care of business there for us?
Yes, I can. Nice.
Just like Jordan said.
Are you enjoying yourself there?
It's like gone. Yeah.
So it was really necessary for you to call that.
Yeah.
You know what? I'm gonna say it. You're almost as bad as Betty. Oh my God. That what? No. Not my problem.
Oh, so much effort.
Yeah. That was not. Did you fix it? Grabbing the paper? Yeah, I'll take more effort.
Dude, these questions by yourself. It takes 5 minutes. It literally took me 5 minutes. Do all of them. No. I'll go back to here.
There's 8 of them?
She literally dies. There's like, you said the same thing, you basically have a question. She brings pity to everyone, and then she dies.
Dude, it's Shakespeare. I don't know what's going on, alright?
So like, okay, so.
Okay, no, I've read the sections.
I'm gonna
We have a
explain.
skill. Hazmat.
Basically, it shows that like she actually like did care for her dad, even though
Okay.
he like used her and stuff, and then it drove her nuts, so I would like contrast how he like could have reacted when he died, when like his dad died, because like she went mad, but like really mad. So it just provides more evidence that he was actually mad because he was like all those things that she did. Yeah.
How am I supposed to word that? Hate you ways.
Because like all the questions, like they ask different things, but that's the basic gist of what we're doing.
Why? He has two, just like. You're right. Well, not like school.
That's what we're doing. So it's not like you even have like fully thought out answers.
Let that what I want.
You know?
Oh my gosh, that's so nice.
Everything's coming together.
No, she got it for like all of them. There's like 4 boxes. Oh, that's so nice. A little treat. Give a little snack with it.
Billy, what's this teacher's workout today that needs you? Need you?
Yes.
Oh, man. Are we gonna, do we have a bell today? We always have bells? Oh. Well, do you guys want to go, let's go over your homework. Yeah. Woo!
I have questions on two ones. Like I worked them out, but I don't know if I did it right.
Well, I'm gonna go over all of them.
Oh, really?
Yeah.
Like,
You better believe it. So the first one. This is the region, yes?
yeah.
And then the first one, we're going around x equals 1, which is that guy right there. So I do my reflection. And looks like we can stack those up like pancakes. Because when we go around a vertical axis, and we're stacking, like washers or discs, and we're going to stack them like pancakes, that rectangle is horizontal, and they're always dy thick. Right? So this is y equals 2x, right? Okay, so the volume of one of them said pancakes is pi r squared. So what's the radius of that thing? It's 1 minus whatever that x value is right there, which is y over 2. So that's one of them discs. And then we're going to stack them up from 0 up to whatever that y coordinate is there. And what is that y coordinate? Well, it's 1, 2. Okay? All right, so that one wasn't too bad. Next one was x equals 2. Oh, okay. I'm going to fix that one just because it looks kind of janky. All right, so here we go. Ready? Draw that rectangle. So now, pi outer radius. The outer radius of this washer is the distance from here to there. Okay? Which is, this is x equal 2. That distance is 2 minus y over 2. Yes? And the inner radius is the distance from here to there, which is 2 minus 1. Now, do you want to call that 1? Certainly. Call it 1. Go ahead, knock yourself out. Okay? I'm going to write it like this so we see that he came from 2. Okay? And then we're dy thick. And then what do we stack these up from? Samuel? 0 to 2. Notice the bounds didn't change. Yeah. Bounds didn't change. Oakley dokley? Yeah.
As long as you're rotating around the same or a parallel axis.
Say that again.
So the bounds ever change?
No. No. If we're rotating around a horizontal axis, the bounds are all. I'm sorry. On this one, if we're rotating around a vertical axis, the bounds are always going to be 0 to 2. because they're the bounds for which that region is defined, and they're the bounds for which those washers work. Yeah.
Would there be a case where you're working around a vertical axis, but it's an integral in terms of x? Just because like it's not possible to. or
Yes,
easy to
I'm going to
do.
show you that today. Yeah, you're going to see that today. What's the next one? The next one I think is y squared, x equals, or y equals x squared. It's a parabola. And y equals 1. So I'm going to go ahead and label this point here as 1, 1, yeah? And I guess this point here is negative 1, 1, okay? And what's the first one we have to do? What's the first one they wanted us to do? Y, rotate that around y equals 1, which is this axis. Oh. It's going to look like a football. Okay. So this is a horizontal axis, right? So we got them shells. I'm sorry, them discs. Yeah. What's the volume of one of them pancakes that we're stacking, or discs that we're stacking like library books? It's pi times, what's the radius of this disc here? It turns out it's that distance right there. What is that distance right there? What is that distance right there?
Is it 1 minus x squared?
It is 1 minus x squared. And then we're going to stack these up like library books from where to where? Negative 1 to 1. Okay? Now, someone asked me a really good question last period that's worth showing you guys. They said for this particular problem, could I have stacked like pancakes? I said, okay, well, let's look at that. What's the radius of that? Well, if this is y equals x squared, that radius is x equals radical y. Right? So it'd be pi times radical y squared dy, and then stack them up. From where to where?
0 and 2.
And that's what they thought. 0 to 2. But that's not right. What do you think?
0 to 1.
0 to 1, but then you got to double it. Because 0 to 1 is only going to give you half the football. We'd have to use symmetry to get the whole football. Now, why does 0 to 2 not work? Very interesting. Because x equals radical y continues on like this. Right? And when you get above 1, them discs are too big. They're outside of that. See that? So 0 to, and that's what this person had. They had 0 to 2. It's like, why is that not right? If you do this calculation right here, and you do this calculation right here, you'll get the same answer. Okay? Okay. Good stuff. What's the next one that we had to do, though, for this football shape? Y equals 2? Okay, let's do it, baby. Oh, yeah. So this is a horizontal axis, right? So the way that we do these, if it's a horizontal axis, we stack like what? Like library books, right? So our washers look like that, yeah? Okay, friends. It's so important that we draw a nice picture so that we can measure these distances. Okay, and when I say measure them, I don't mean like with a ruler. I mean figure out how long they are. Like, you know. So now, here we go. Now I'm jumping through the volume of one washer kind of thing. I'm just jumping right to the integral. So the outer radius of this green washer, the outer radius is the distance from here to there. What is that distance? It's 2 minus x squared. The inner radius is the distance from here to right there. And what is that distance? It's 2 minus 1. And then we add those up from x equals -1 up to x equals +1. Okay? Just like we use -1 to 1 over here. Okay? Questions? Okay, now before we do this last one, I want to ask you a question. It's like 6th grade math. What's the distance between those 2 points?
9.
9. How did you get that?
4 plus 5. -4 to 0 is 4 plus 5 is 9.
Okay. What's the distance between these 2 points? How'd you get that? 15 minus 4. Well, how come you didn't do that here? That's not what she did. She counted, said, well, -4 to 0, 4, and then 5. But isn't that really the same as 5 minus -4? Because the -4 to 0, that distance is really like 0 minus -4. +4, right? Okay. The next problem was take that region and spin it around, I think, y equals -2. Double check. No, -1. Okay, this is probably not the best symmetry here, but that's okay. Are we going to be stacking like library books or like pancakes here? Like library books. Because that's a horizontal axis. Yeah? So I'm going to draw this rectangle. This is the one that everybody has trouble with. Here we go. What is the outer radius? Okay. Now, when we measure, we always measure to the original region. When we're finding these radii, we always go to the original region. If we don't, we're going to screw up. Trust me. All right? So when I'm looking at this outer radius, it's the distance from here to right there. What is that distance? How did you get that?
2 minus -1.
You got that by saying that's 2 minus -1. Okay? 2 minus -1. Wait.
I said 1 minus -1.
Yeah. 1. That's why Kevin looked at me like I had 2 heads. 1 minus -1. And what's the inside radius? Now, everybody look here. The inside radius is the distance from here to there. It's that distance right there. Or if we're over here, it's that distance right there. What is that, Alex? How did you get that? Okay. It's like x squared minus -1. When you did this over here, you said 5 minus -4. Why did 5 come first? Because it was bigger. Right? X squared minus -1 is going to give you that total distance. Or, just like Alex said, that distance right there is 1 plus the x squared distance. Okay? Squared dx, and then -1 to 1. And this does simplify to this, my friends. Okay? But one thing that you need to understand here that's sort of interesting, or maybe not interesting, but one thing that you need to understand, it is very crucial. In this particular setup of finding this volume of this weird donut shape, I mean, what this is like a donut with like perfectly straight outside edges and curvy insides. Okay? What you need to understand that in the context of this particular setup to find the volume, that length right there means nothing. Like that length that I just made green there is nowhere in this. Okay? Questions on that? everyone messes up that second piece, that inside radius on that one. That's the one everybody messes up. Okay. Other questions? All right, let's do this then. So, well, before we switch gears, so what's going to happen is I've already put on the Google problems from the book that deal with this, where you're rotating around the x-axis and the y-axis. And then I think there are a few. All of the ones that I gave you in the book, they're all rotating around the x-axis or the y-axis. So, some of them will involve discs, some of them will involve washers, but you will just be able to stack them accordingly. Okay? So you'll have those to work on tonight. Tomorrow online, I will put either a video of me working all those out, or I'll just give you the answers. I'll probably just give you the answers. And I just focus on the setups, okay? Don't worry about computing them, just focus on the setups. So I'll put the solutions online so you can check yourself. Then on Thursday, we'll finish up what we're about to start right now. Okay? It's just this Wednesday is just awful. Like I could have quizzed you over this Thursday if we didn't have this stupid Wednesday. We could have had a quiz over all this and be done and move on. But this stupid Wednesday in the middle of the week just screws everything up every single time. So this is what it is. Weekend Wednesday. Is that what you guys call it? That's what my 9th period class calls it. Oh, I don't do any work on Wednesday. It's like almost like you're entitled. I don't have to do it like that. It's my day off. It's garbage. Okay, so here we go. You ready? This is kind of alluding to Samuel's question a second ago. So I'm going to give you a region here. I'm going to give you a scenario. I'm going to say here's a region. The region bound by those two graphs. Now I'm just curious. Right now I'm curious. Before we talk about the calculus and doing any rotating or anything, how many of you right now, if you had to, for $1 million, you could sketch this region by yourself with no help from anybody or anything? You could ballpark this region pretty easily by yourself. You all should be able to. I mean, every Algebra 1 student, well, maybe not this year, but everybody who's taken Algebra 1 should be able to sketch this region without any help. At least sketch those two graphs without any help. The first one is the what? It's a parabola. It has zeros where? 2 and 4. Is it smiling or frowning? It's frowning. The graph is practically fell in your lap. The only thing missing is the vertex, which in this particular context we don't even need. But you could probably easily find the vertex because you know the x-coordinate of the vertex is what? 3. It's in between the two, halfway between the two zeros. It always works out like that, right? So this parabola look like that. Yes? which I'm gonna scoot that over a little bit because it's too close. How about these? Yes? Everybody happy with that? And then y equals 0. That's the y-axis. So there's our region. Okay? So we're going to rotate this region around the y-axis. Okay? And when I rotate that region around the y-axis, it's going to look like a bundt cake. Or maybe the top half of a bagel. Right? If you slice the bagel, that's what we're going to end up with here. Okay? I mean, if you really wanted to get fancy, I could probably draw a little. Okay? So, if we were going to do this by stacking something, would we be stacking like pancakes or like elaborate cakes? Pancakes, because we're going around a vertical axis. Okay, so can you draw in one of the discs or the washers? Draw what it looks like. Lightly draw it. I guess I can leave that there. Okay, so you have some discs, or you have one of the washer. I guess it's a washer, right? I'm gonna draw it this green so it sticks out here. You guys cool on that? What's the outer radius? What's the inner radius? You see a problem. You should see a problem. What's the problem that you see? Billy, do you see a problem?
Sort of.
Sort of. What are you seeing?
Like no, like stable side.
What?
Neither side is like stable, I guess. Like it's all gonna be different.
Well, that's always the case. The radiuses are changing. But this one right here is measured from there to there, right? And it's measured by, it's on that curve, right? But this one right here is the distance from there to there. It's also on that curve. Do we see that being problematic? Because how are we going to set that up? Like you'd have them subtracted from each other. The problem with this is that equation, that parabola, is not a one-to-one function. Whoa, remember that word? That parabola does not have an inverse that is a function. That parabola fails the horizontal line test. I can't solve that parabola for x in terms of y. I can write it y as a function of x, but I can't write it as x as a function of y. Okay? So I cannot do this one by stacking like pancakes. Okay? So that sucks. So I'm going to erase this. You probably will have to draw a new picture unless you have one of those fancy white erasers. Okay, well, shoot. How are we going to do this? Have any of you ever seen those Russian dolls? You know what I'm talking about, Russian dolls? What'd you call them? Sure. I didn't know that. Like, they don't really stack. They like nest inside of each other. Like, you know, there's one doll and you take it apart and then there's the other one, right? And then you take the next one apart and there's another one, right? Okay, they're nested Russian dolls, okay? Or like if I take this tape measure here and I make a solid out of this tape measure, okay? Yeah, you guys see that little solid? You guys see that little solid? Okay? This looks like a bullet, right? Kind of. Or a rocket tip. Space capsule, maybe. But if you think about this shape here, you can really think of this shape as a bunch of like nested cylinders. I mean, you can see them. Like, in fact, if you look at it like this, you can see them. There's just like, there's a cylinder, there's a cylinder, there's a cylinder. And they're like, you know, the cylinders are changing in size and they're changing in height. Right? Well, what would happen if instead I drew that rectangle that we drew before, instead of drawing it horizontally, I drew it vertically. And I rotated that rectangle through the axis. There's a cylinder, or half of it at least. And then like over here, maybe here's another one. Once you draw one, it's kind of hard to draw two because you can't, it's hard to see them both. But do you see how that solid, that bagel, could be thought of as a bunch of cylinders of varying height and radius, I guess, being nested on top of each other, or not on top, or nested together, I guess. Most textbooks call these cylinders shells. And I actually did not realize why they were called cylindrical shells until like about 3 years ago. I went to a shooting range. And I shot like a handgun at a shooting range. We did it. It was like I went down to my sister-in-law and her husband and their family at Christmas time. On Christmas Day, we went to the shooting range as a family. Like, what an activity, right? On Christmas Day, family activity. That's what you do in the South, I guess. You go shooting. But when you shoot a gun, if you've ever shot a gun or seen a gun shot on TV, what falls onto the ground? What falls out? The shell casing. And what is that shell casing? It's a little cylinder. It's really thin. It's like a little, oh my gosh, that's why they're called cylindrical shells. Okay? What's the volume of one of those things? Well, that's what we got to figure out. Because if we can figure out how to like, this is what a cylinder looks like. It looks like this piece of paper, okay? It's really, really thin. And it's hollow. What's the volume of this? Now, when I'm saying the volume of this, I'm thinking about the volume of the material, not how much this will hold. You understand what I'm saying there? Like when I make this cylinder, I'm not talking about how much will this hold. I'm talking about the volume of the material. Okay? You follow me there? Well, what is going to be the volume of this material? Well, how thick is it? Well, how thick is this? It's infinitely thin, but if it's drawn vertically like that, how thick is it? What are we going to call that infinitesimal? We're going to call this dx, right? In fact, if I unroll that cylinder like this, I basically have a sheet of paper like this, right? It's dx thick. What's the volume of that little piece of paper? Length times width, right? Well, hold on the phone here. What's the length, if you will? It's just the circumference of that thing, right? And what's the width? It's that distance right there. Well, what is that length right there? It's the y value on the curve, right? So it's negative x minus 2, x minus 4. Well, what's the circumference of that thing? Well, the circumference of a circle is 2 pi r, right? That's the circumference of a circle. And do you see that depending on what x is out here, I mean, if x is right here, the radius of that cylinder is going to be 2. But if x is way out here, the radius is going to be much bigger. What is the circumference of that cylinder? Let's back up. What is the radius of that cylinder? It's just whatever x coordinate you're sitting at. So if I draw my shell right here at x equals whatever, the radius is x equals whatever. But if I draw that rectangle out here at x equals whatever plus something, the radius is x equals whatever x plus something. It's whatever the x coordinate is. So the circumference is 2 pi x. So when I unroll it, it's length times width times height. The volume of that slab, the volume of that shell is 2 pi r h times the thickness, or 2 pi r h times dx, because we said dx was the thickness. It's 2 pi r, what's h? What's that distance there? Or what's that distance right there? That's the h. It was negative x minus 2, x minus 4. And what's the radius? I'm just building this up each time here. So that final thing that we just wrote down here. What is that? What is that circle? And what is it? It's the what about it? It's the volume of a singular shell that's located at x equals x. Okay? So if you wanted the total volume, what are you going to do? Add up all of those little volumes from where to where? From where, Carrie? 2 to 4. We'll finish that on Thursday. So yeah, I'll see you. Check the Google. It's probably something that I'm gonna skip in here. I shouldn't say that on camera, but I don't know if it's. Let me see. What's that? Yeah, we're probably gonna skip it. You learn it in Calc 2 though.